Hello everyone, I'm Zhenpeng Chen from Peking University. In this presentation, I'm going to talk about our recent work on challenges in deploying deep learning-based software. This is a joint work with Yanbin, Yuanqiang, Xuanzhe from Peking University and Haoyu from Beijing University of Posts and Telecommunications. Deep learning has been used in a wide range of software applications from different domains, including image processing, speech recognition, natural language processing, and autonomous driving. This deep learning-based software, in short of deep learning software, has become a crucial topic in the software engineering research community. Many research efforts have been devoted to characterizing the challenges that deep learning poses to software development. In the development process of deep learning software, developers use deep learning frameworks such as Keras and TensorFlow to implement deep learning programs that encode the structure of deep learning models and the process by which the models are trained using the training data. To characterize the challenges that developers encounter in this process, various studies focus on analyzing faults in deep learning programs. Recently, the great demand of deploying deep learning software to different platforms for real usage also poses new challenges to software deployment. For example, a computation-intensive deep learning model in deep learning software can be executed efficiently on PC platforms with the GPU support, but it cannot be directly deployed and executed on platforms with limited computing power, such as mobile devices. To facilitate the deployment process, major vendors have rolled out related frameworks for deep learning software deployment. Specifically, developers can use these frameworks to convert deep learning model into the format expected by the deployment platform. Then, the converted deep learning model can be integrated into software application so as to run on the deployment platform. During the integration phase, developers need to configure the environment, import deployment-related framework into the application, configure the way that the deep learning model is loaded, and so on. In addition, to provide services for real users, developers need to implement the interaction between the deep learning software and the users, including how to extract and pre-process data from users, and how to post-process data to show the inference results to users. The complicated deployment process brings a lot of difficulties to developers. However, to the best of our knowledge, the specific challenges that developers face when deploying deep learning software remain under investigated. To bridge the knowledge gap, this paper presents the first comprehensive empirical study on identifying challenges in deploying deep learning software. Given surging interest in deep learning and the importance of deep learning software deployment, this study can tell developers common pitfalls and make researchers and framework vendors better positioned to help software engineers perform the deployment task in a more targeted way. To understand the challenges developers encounter in practice, we analyze the relevant questions from a variety of developers on Stack Overflow. In this study, we select 3 representative deployment platforms of deep learning software for study, including server cloud platforms, mobile platforms, and browser platforms. For server cloud deployment, we extract questions tagged with TF Serving, Google Cloud Machine Learning Engine, and Amazon SageMaker. TF Serving is a deep learning framework that is specifically designed for deploying deep learning software to servers, while Google Cloud Machine Learning Engine and Amazon SageMaker are 2 popular cloud platforms that can be used for deploying deep learning software. For mobile deployment, we extract questions tagged with TF-Lite and CoreML frameworks. For browser deployment, we extract questions tagged with TF-JS. Then we perform a regular filtering procedure and have a total of 3,023 questions for further analysis. Specifically, we focus our analysis on the following research questions. In the first research question, we studied the popularity trend of deep learning software deployment on Stack Overflow. In the second research question, we analyze the difficulty level of deep learning software deployment through comparison with other well-studied challenging topics in software engineering. In the last research question, we construct a taxonomy of specific challenges in deep learning software deployment. To illustrate the popularity trend of deep learning software deployment, we calculate the numbers of users and the questions related to this topic per year. Results indicate that deep learning software deployment is gaining increasing attention, demonstrating the timeliness and urgency of this study. As for difficulty level, we use two well-adopted metrics, including the percentage of questions with no accepted answer and the response time needed to receive an accepted answer. Compared to questions related to other aspects of deep learning software and other well-studied challenging topics in software engineering, such as big data, concurrency, and mobile, questions related to deep learning software deployment have a higher percentage of questions with no accepted answers and often need longer time to receive accepted answers. This finding indicates that questions related to deep learning software deployment are difficult to resolve, motivating us to further identify the challenges behind this topic. Let's move on to the last research question about the specific challenges. First, we randomly extract a statistically significant sample, including 769 questions from the raw dataset. Then, we follow an open coding procedure to inductively create the taxonomy of challenges in deep learning software deployment in a bottom-up way by analyzing the sampled questions. The taxonomy for each kind of platform is constructed individually based on its corresponding samples. Each taxonomy is hierarchically organized into 3 level categories. In total, we have 25 inner categories, such as model conversion, and 72 leaf categories, such as model quantization. As shown in the figures, developers have difficulty in a broad spectrum of issues. Due to time limit, I'm going to share some representative categories, and more details can be found in our paper. First, we introduce the challenges in the face of model conversion. Model conversion covers the most encountered category of challenges in mobile, and the third most encountered category of challenges in browser. Specifically, model conversion category covers challenges in converting deep learning models in deep learning software into the formats supported by deployment platforms. We next present 4 challenges under this category, including unsupported models, specification of model information, selection and usage of APIs, and model quantization. The support of deep learning on some platforms is still unfledged. Some standard operators and layers used in the trained model are not supported by deployment frameworks. Therefore, conversion of unsupported models is a common challenge during model conversion. For example, developers report that Gaussian noise is not supported by TF-JS. In addition, some developers report that they could not deploy the RNN models such as the LSTM models to mobile platforms due to the unsupported operation error, which is also observed in previous related work. When converting deep learning models to expected formats, developers need to specify model information. For instance, TF serving requires developers to construct a signature to specify names of the input and output tensors and the method of the inference. Sometimes, developers directly use off-the-shelf models that have been well-trained and released online for deployment. But the developers have no idea about the model's information, making the model conversion task challenging. There are so many APIs provided by different frameworks for developers to convert models to various formats. Therefore, it is challenging for developers to select and use these APIs correctly according to their demand. For example, TF Lite provides 7 APIs for model conversion. What's more, the addition deprecation, and upgrade of APIs caused by the update of frameworks also make the selection and usage of APIs error-prone. Model quantization reduces precision representations of model weights. For instance, TF-Lite supports converting model weights from floating points to 8-bit integers. This technique can reduce power consumption, memory cost, and computing overhead of deep learning models in deep learning software. Therefore, it is mainly used for deployment to mobile devices due to their limitations of computing power, memory size, and energy capacity. For model quantization, developers have difficulty in configuration of relevant parameters and call for more quantization options. In addition, we observe some challenges that developers encounter during integrating deep learning capacities into software applications. Challenges related to this phase account for a large proportion of questions in deep learning software deployment. In particular, questions related to the configuration that deep learning model is loaded, i.e. model loading, is the most encountered challenges in broader deployment, accounting for 24% of questions in broader category. For broader platforms, there are 3 ways for model loading, including loading from local storage, HTTP endpoints, and IndexedDB. Among the 3 ways, we observe that the main challenge lies in loading from local storage. In fact, the local storage refers to the browser's local storage. However, many developers attempt to load models from local file systems. We next move on to the challenges in the interaction between deep learning software and users. The most common challenge in this phase is data processing. It is the most encountered challenge in server cloud platforms, accounting for about 20% of questions. Specifically, data processing category covers challenges in data preprocessing and post-processing. Data challenges in converting raw data into the input format needed by deep learning models in deep learning software, and converting the model output into expected formats. We then present 3 challenges under data processing, including migrating pre-processing, setting size, shape, format, data type of input data, and parsing output. When deep learning models are developed, data preprocessing is often considered as an individual phase, and thus may not be included inside the model structure. In this case, code for data preprocessing needs to be migrated during the deployment process in order to keep consistent behaviors of software before and after deployment. For instance, when developers deploy a deep learning application with preprocessing implemented with Python and out of the deep learning model to an Android device, the developers may need to re-implement preprocessing using a new language such as Java, re-implementing preprocessing incorrectly, or forgetting to re-implement it can lead to faulty behaviors. Setting size, shape, format, data type of input data is another common challenge in data processing. A faulty behavior manifests when the input data has an unexpected size and shape or unexpected format and data type. The last leave category in data processing is parsing output. It includes challenges in converting the output of deep learning models to expected or human-readable results, such as parsing the output array or tensor to get the actual predicted class. Besides data processing, in server cloud deployment, developers also encounter unique challenges in the interaction between deep learning software and users. The unique challenges include request and serving, which together account for about 26% of questions in server cloud. Request covers challenges in making requests in the clients. For request, developers have difficulty in configuring the request body and sending multiple requests at a single time, that is, batching request. Serving concerns challenges related to serving deep learning software on the server cloud platforms. Many developers encounter challenges in authenticating a client and parsing the request. In addition to process requests in batches, developers need to configure relevant parameters manually. However, some developers have difficulty in this configuration. For mobile and browser platforms, developers also face unique challenges in the deployment process, such as model security and inference speed. We first introduce model security. Deep learning models in deep learning software are often stored in unencrypted formats, resulting in a risk that competitors may disassemble and reuse the models. Any challenges related to model security are included in this category. This category is observed only in mobile and browser, since models deployed to the two platforms are easier to obtain. In contrast, models deployed on server cloud platforms are hidden behind API calls. As for inference speed, it has been a challenge in mobile devices and browsers, since the two platforms have weaker computing power compared to server cloud platforms. At last, I'd like to give a quick summary. In this study, we analyzed the deployment of deep learning-based software based on Stack Overflow questions. We demonstrated the popularity and difficulty level of this topic. Furthermore, we built a taxonomy consisting of 72 categories linked to challenges in deploying deep learning software to server cloud platforms, mobile platforms, and browser platforms. You can find more details in our paper if you are interested. Thanks for your attention.